Hello and welcome to my video about linked lists. I wanted to put together a video on linked lists because conceptually they can be a little bit tricky to get your head around at first, and I think there's a lot of important concepts for you to understand there. So I figured I'd put a video together to help explain these concepts. So for a start, just looking at the linked list struct itself. So hopefully you've seen this struct node over here before. So this is what we refer to as the node struct, the struct node here. I've drawn some pictures over here about what it would look like. But basically, a node struct has two things. One of them is some int data, so that's a number that's stored inside the linked list. And then the other one is this struct node star next. And so this is what sets linked lists apart from normal structs. The fact that they have this link to take you to the next node of the list, the next node in the list, and so on. So we can use linked lists for storing lists of data. In this case, the linked list is just a list of ints, but in the assignment, for example, you've been looking at lists of Pokemon. So it can be really useful to have a list where we can insert and remove items really easily, because compared to an array, with an array it's very hard to add something to the middle or remove something from the middle. So linked lists are great for that. They're great for a whole bunch of things, but it's important that we understand the fundamentals of how they work so that we can make the most of them. So like I said, this is how I've drawn up my node struct, and I'm going to be making a lot of use of these little diagrams here in the video. So just a reminder, this next field here is a pointer here, struct node star next, and that's the linked part of the linked list. That's the link to the next node in the list. And then the second thing down here, this int data, that's the data that's stored inside the list. So this is what I'll be drawing my linked list nodes like. One other important thing to mention is this x at the end here. This is how I represent null. So when a list's next field points to null, I'll just draw it like an x, like this. Cool. So conceptually, there's a really important thing that I want to talk about first, which is the difference between a struct node star and a struct node. I know this is something that can take a while to fully understand, but I think it's really important to understand the distinction between a struct node star and a struct node itself. So this is a common line that you might see in your code. Struct node star new equals malloc size of struct node. So what this line does, looking at it from right to left, it calls malloc, and it asks malloc for size of struct node amount of memory, so enough memory to fit a struct node. It then stores the address that malloc returns in a pointer called new of type struct node star. So this struct node star new, this new variable here, is just a pointer. It's just an arrow. It's just like this thing down here. That doesn't have any memory itself. That's just a way of getting to some memory. And then on the right-hand side over here, this malloc size of struct node. This is the actual piece of memory that we've gotten back from malloc. So the important distinction there is that a struct node is an actual blob of memory, whereas a struct node star is just an arrow to some memory. So we will be making very frequent use of these struct node stars, of these node pointers, as we work with our linked lists. So for a start, one really important concept, there are two common loops that you'll have with linked lists. So if you think about arrays, you've got your, int I equals 0, while I is less than 10, I++, that sort of structure of a loop to go through an array. We've got the same thing for a linked list, the sort of core structure of how to loop through a linked list. But there are two slightly different versions of it, and it's really important to make sure that you use the correct one in the correct situation. So this one over here, loop number 1, I've said, do something with every node. So this is a loop that will do something with every single node in the list. So for example, do something with this node, then this one, then this one, then this one, then it'll stop. So in comparison, we have what I've called loop number 2 here, which is do something with the last node. So this is a loop where we'll stop when we get to the last node, and then we can do something with this. So for example, we could return the last node, we could add something after the last node, and so on. But for a start, let's just look through these loops and what the code actually does. Starting with loop number 1 over here, the first line here is this struct node star current equals head. So remember what I said before, this struct node star current means that current is just an arrow that will point to some piece of memory that was given to us from malloc at some other point in time. So I'm going to draw current like this over here with this green arrow here. So struct node star current equals head means current points to the same thing as head does. So that's this first node here. So my loop condition is then, while current is not null, then in the body of the loop, you'll do whatever you want to be doing with that list. So maybe printing them out, summing the values, or whatever. And then finally, we have our current equals current arrow next. So this is the equivalent of the I++ that you might have in an array loop. This is the way that we move from one iteration of our loop to the next one. So let's look at this diagram in terms of what this code is doing. We've got this first line here, struct node star current equals head, so that's made us our current down here. We then say while current is not null, so we check is current null? Nope, it's pointing to this node here, so that's good. So we go inside the loop. We would then do something like maybe print it out or whatever, but for now we'll just do nothing there. Then we have this line current equals current next. So what this means is that the variable current, which is this arrow over here, this variable is equal to the next field of the thing that it is pointing to. So this is a really important concept to understand to make sure that you know where to put the arrows, for example, which side of the equals sign to put the arrows. But in this case, when we say current equals something, that means that we're just changing where this arrow is pointing to. So in this case, current equals current next means that this current pointer here is now going to point to the thing that is at the current node's next field. So this is current, this is the current node here. The current node's next field, this one here, points to this node over here. And so current is now going to point to this node over here. So now we've hit the end of our loop here. We go back around, we check our loop condition again. While current is not null, well, it's not null, it's pointing to this node here, that's a node, so we go inside the loop. We then do something, maybe print it out, whatever. Then to go to the next iteration of the loop, current equals current next. So again, the same thing. This is current. So we go to the thing that current is pointing to, this node here. We then go to its next field, which moves current to be pointing at this node over here. So I'll just rewrite the word current so that it fits better over here. Current is now pointing to this node here. And so then we go around our loop again. We check our loop condition. While current is not null, well, it's not null, it's this node here, so that's fine. Do whatever's in the loop, so just nothing here. Then current equals current next again. So current over here, this arrow has the value of whatever this node's next field is, which again happens to be this node along here. So current equals current arrow next means that current is now pointing to this node over here. So again, we go back around our loop, we check our loop condition again. While current is not null, well, current's not null, it's this node here with a 5 in it, so that's all good. We do something, maybe print it out, whatever, nothing in this case. And then again, we say current equals current arrow next. So again, this is current, this arrow here is current. We look at the next field of the node that it points to, which in this case is pointing to null. So this means that when we make current be equal to the next field of this node, current becomes null. So I'll draw that as current pointing to this x over here to show that it's null. So then we go around our loop once again. We check our loop condition. Well, current is not null. Well, current is now equal to null, so we stop. We don't go back inside our loop. And then once we hit the end of the loop, like I've got at this comment here, at this point, current is null. So this is one of the really great things about loop conditions, right? We know that if our loop is going to loop while current is not null, then we're guaranteed that once we've finished the loop, this is no longer going to be true. So current is no longer going to be not null, which means current is going to be null. So what this means is that if we tried to do something with current at this point, for example, at this point, if we said something like current arrow next equals blah, we'd be trying to work with null, and you can't do anything with null, you can't dereference null, you can't have null arrow something, it's just null. So you would get a segmentation fault with that, or a runtime error with DCC. So when you have a loop like this loop number 1, while current is not null, once the loop has finished, you can't do anything with current. Current is now null. So let's compare that to this loop I've got over here, loop type number 2. So this is the sort of loop that you want to use when you're doing something with the last node. So for example, if you want to add a node to the end of the list, you need to first find the last node in the list. And so that's an example of what you could do with this loop here. So again, I'll walk through this code, look at what it's doing in terms of this diagram, and we'll see what it does and how it's different to the last one. So the first line again, struct node star current equals head. So that means we make a struct node star, a struct node pointer, just an arrow, called current, and it points to the same thing as head points to, so they both are pointing to this first node here. So then I have while current next is not null, so I check current is here, current arrow next, this one here, well that's not null, that's a node, so that's fine, I go inside the loop. I then maybe do something, maybe not, and then I go current equals current arrow next. So again, current is here, current arrow next refers to this node's next field here, which is this node here. So that means that I make current now point to this node over here. So then again, I come back around my loop condition, I check the condition again, while current next is not null. Well, current, this pointer here points to this node, its next field is this node here. That's not null, so we're going to go inside the loop. Again, we don't do anything else in the middle of the loop, and then we just say current equals current arrow next. So again, current here is now pointing to this node over here with the 4. So now once again we go back around our loop, we check our loop condition while current next is not null. Well, here's the current node, current next is this 5 here, so there is a node there, so it's not null. So we go inside the loop, and then we just go current equals current arrow next. So current is now pointing to this node over here with the 5. So we go back around our loop again, we check our loop condition again. Well, current next is not null. Well, current is this node, current next is null, so we stop, so we finish our loop. And so now that we've finished the loop, we're at the end of the loop, we know that at this point, current is the last node in the list. So whereas with before we had our current was null when we were finished with our loop, with the second style of loop here, current is pointing to the last node. So this is super useful if we want to do something with the last node. For example, if we wanted to add a node to the end of the list. So we would use this loop, we would get to the point at the end after the loop where we have this current pointer pointing to the last node, this one over here. And then we could do something like, for example, current arrow next equals some other node to insert this node here into the end of our list. So before we move on, I just want to really emphasize the difference here between these two loops. Loop number 1 goes while current is not null. At the end of the list, current is null, and so current pointer over here is pointing to null, so we can't use current to do anything. It's at the end of the list, it's done. Whereas loop type over 2 we have here, the difference is at this condition as well, current next is not null. So this sort of loop is going to stop once current is pointing to the last node on the list, rather than off the end. So while current arrow next is not null, means that when we finish that loop, current here is pointing to the last node in the loop, so we can still use this node. We can still do something with this node. Cool, so let's look at how that would work in terms of some actual functions that do something more than just looping through. So let's look at this function I've got over here. It's called listSum, and this function sums up all of the values in this list that's pointed to by this pointer head here. So similar to the last diagram, I've got my list over here. I've got this head pointer here, which is just an arrow pointing to this node here. And my goal is to sum up all of the values of the items in the list. So looking at the code, first of all I have struct node star current equals head. So this means create a pointer called current. And remember, a struct node star is just an arrow pointing to somewhere, not an actual node itself. So in this case, make current point to the same thing as head points to. Then I make another variable here in sum equals 0, so I'll just write that over here, sum equals 0. And then I'll update this as I go through my list. So now I have my loop condition while current is not null. So this is going to be one of that first type of loop I had before, where it does something to every node in the list. So looking through this, while current is not null, well it's not null, it's pointing to this 3 node here. Sum equals sum plus current arrow data. So that means we have our current pointer here, we go to the node that it's pointing to, we go to that node's data field, and then we add that value to our sum. So 0 plus 3 is going to be equal to 3, that's an easy one. And finally we have current equals current arrow next. And so again, this one, current equals means we're changing where this arrow points to. Current equals current arrow next means we go to the thing current is pointing to, this node here. We go to its next field, which is pointing to this node here. And then we make current point to that node there. So current will now be pointing to this node here. Cool, so let's go around the loop once again. We go back to the top, we check while current is not null, while it's pointing to this node here, which isn't null, so that's good, we go into the loop. Sum equals sum plus current arrow data. So our sum variable over here is currently 3. We're going to add to that this 1 from the data field. So remember, current arrow data means look at the node that's been pointed to by this current pointer, look at its data field, and then add that to our sum. So 3 plus 1 is, funnily enough, 4. Cool, so then once again we go to the next line, current equals current arrow next. So that means current here, this arrow here, is going to point to the next field of this node, which is this 4 over here. So now we've reached the end of our loop, we go around again, check the condition again. While current is not null, well it's not, it's this node here with a 4 in it. Sum equals sum plus current data, so 4 plus 4 gives us 8. Then finally, current equals current arrow next. So current now points to this node over here. So we go back around, we check our loop condition again. And this is where this first sort of loop differs from the second sort of loop. Because our condition is, while current is not null, we are going to process every single node in the list. If our condition was, well, current next is not null, we would stop at this point. We wouldn't keep going because this one here would be null. But that would mean that we didn't add this 5 to our sum. We'd miss out on actually summing all of the values. So that's why it's important we have this first type of loop, while current is not null, to make sure that we process everything in the list. So again, we look at our loop condition. While current's not null, it's this node over here. We add its data field to our sum, so 8 plus 5 is 13. Again, we then do current as current arrow next, so that's this null over here. So current now points to this null here. We then go back around, check our loop condition again. While current's not null, well, current is null, it's pointing over here. So we finish this loop, we go to this bit here after the loop. So I accidentally forgot to return sum at the end of my function, so I'll add that in real quick. And now my function is complete. So just summarizing this function again, it's called listSum. It sums all of the values in the list that's pointed to by this node here, head. So the way that this worked, this was the first type of loop that we have, while current is not null, where we process every node in the list. So as we went through, our sum down here started out as 0. We then looped through all of the nodes in our list, and each time we went to a new node, we added its data value to the sum. And then at the end, we summed up all of these values, we got 13, and then finally we return sum, so this function will return the number 13. So hopefully that one's made sense. Let's look now at an example of the second sort of loop. So let's have a look at this add to end function. This is an example of that second sort of loop I said, while current arrow next is not null. So rather than just while current is not null, while current arrow next is not null. So importantly, this is the sort of loop that I said will stop when it gets to the last node. So with this loop, we can then do something with the last node in the list. So let's walk through this code, let's look at it in the diagram and see how it goes. So first of all, we started again with this good old line here, struct node star current equals head. So struct node star means pointed to a struct node, which means an arrow. So I make myself a new arrow over here called current, which points to the same thing as the head node points to. So now I have my loop condition, while current arrow next is not null. So we look at current, this pointer here, which points to this node here. We look at its next field, which is a valid node over here, so that's all good. We do go into our loop. The contents of our loop is then literally just go to the next node, so current equals current next. So we make current point to this next one over here. We then go back to the start of the list again, while current next is not null. Well, current next, this one here, it's not null, so we go into the loop. And then we just make it move to the next one, so current equals current arrow next. Whoop, over there. And now we check around our loop again. So once again, while current arrow next is not null, well, current arrow next is this node over here, this 5, so it's not null, so we do go into the loop. And then we just do this again, current equals current next, so we move it to the next one over here. We then go back around, check our loop again, while current next is not null. So in this case, current is pointing to this node here, and its next field is null, so we stop. We don't go into our loop, we get to this point here at the end of our loop. So finally we have this line of code, current arrow next equals to add. So this is the key line of code that actually adds the node to the end of the list. Looking at it in detail, we have current arrow next. So what this means, whenever you have something with an arrow on the left-hand side of the equals, so for example, current arrow next equals something, that means that you're actually changing something about the node that it's pointing to. So current arrow next equals something on the left-hand side of the equals means that we're changing the next field of the thing that current points to. So on the other hand, if we just had current equals to and, so on the left side of this equals we don't have an arrow, we just have current, what that means is we're just changing where current points to. So we're not actually changing the node that it points to, we're just changing where this arrow points to. So for example, this line current equals to add would make current, the pointer, now point to this node over here. But that's not what we wanted to do, right? We wanted to make this node's next field join to this one here to add it into the list. But instead we just changed where current pointed to. So remember, on the left-hand side of the equal sign, if you have an arrow, so current arrow next on the left-hand side of the equal sign, means that we're changing something about the node that it points to. Whereas if we don't have an arrow on the left-hand side of the equal sign, if we just have current equals to add, we're just changing where current points to. We're not changing anything about the node that it points to. But let's look back at the example that we had from before. So current here was pointing to this last node on the list. We finally have this line of code, current arrow next equals to add. So again, we've got an arrow on the left-hand side of the equal sign, which means we're going to do something about the node that current points to. So in this case, current arrow next means we follow this along to the node that it points to. We then look at that node's next field, this one here, and we change that to point to this node to add. So that will look like this. So what we've done here is we've now added this node here, this toAdd node, to the end of our list. So remember, the way we did this is we went through our list. We have one of these type 2 loops where we have while current next is not null. So we stopped at the end of our loop while current was pointing to this last node here. We then made that last node's next field point to this node over here called toAdd that we wanted to add to our list. And that's it. We've added the node to our list. Simple as that. One thing that you might want to do at this point is to make sure that you've set the toAdd's next field to be null. In this case, I set it to null already before I passed it into this function. But if you haven't already set it to null, if it's just uninitialized, for example, you'll get some really weird errors happening. So you might want to also add the line to the end of this function. So something like this, toAdd arrow next equals null, and that will just guarantee that this node over here points to null to make sure that it's very definitely clearly the end of our list. So hopefully that one's made sense. This is just an example of the second sort of loop that we have for linked lists, where the condition is while current arrow next is not null. So the really important difference there, while current arrow next is not null, means that we're going to stop with current pointing to the last node in the list. So if we want to do something with the last node in the list, we need to have the loop condition while current next is not null. Whereas if we wanted to do something like the previous one, sum all the values in the list, we need to have our condition be like the first loop type, while current is not null. Because remember, if our condition is while current next is not null, we stop once we get to the last node, which means we don't process that node, we don't add it to the sum, for example. So just to summarize that one last time, in this video we've looked at the two sorts of while loops that we have for looping through linked lists. The sort that I've called type number 1 while current is not null. So this sort of loop will go through every node in the list, it will process every node in the list, and it'll do something with each of those nodes. So compare that to the second type of loop that I talked about, while current next is not null. And so this one will keep looping until current next is not null, so at the end of the loop, current will be pointing to the last node in the loop, which is really useful if we want to do something, for example, like adding a node to the end of the list. So that's it, that's the end of this video. I hope you've enjoyed it. Let me know if it's useful, let me know if you'd like me to make more videos like this. And as always, if you have any questions, feel free to post them on the course forum, and otherwise, I'll see you in my next video.